Okay, so this is really the same idea as what we've already been doing. We've been solving systems by graphing these equations and looking for the place where they cross. We are still looking for the place where they cross, but this is a more mathematical way to do it. This is a way to do it without having to draw a graph every time, okay? Which I know you're probably not crazy about. I know I don't want to graph every single one of these. So this particular method is called substitution. We're going to work on this method today and tomorrow, and then there's another one next week that we're going to learn too. So by the time we get to the end of this chapter, you're probably going to have 4 or 5 different ways that you could solve one of these. You do have a quiz next week, Friday, where I specifically say, solve this by substitution, solve this by elimination. Okay, so you will have to know the difference. But by the time we roll around to your chapter test, I'm just going to hand them to you and I'm going to say solve them. And you can solve them in whatever way works best for you. If you want to do elimination or substitution, all of those words will make sense in the next few days. Okay? So just so you have an idea where we're headed. With substitution, the key to doing this is you have to have one of the equations solved for one of the variables, meaning one variable somewhere needs to be by itself. You're used to getting y by itself, and that's what I see a lot of the times is that when students do this method, they would get y by itself because you're just so used to getting y by itself. That's fine, but sometimes there are situations where it's actually easier to get x by itself, and that's fine too. You can get either variable in either equation by itself. And sometimes it's nice, like number 1. See how number 1 already has y by itself? Then you don't have any work to do to get started. Okay, you can just jump right into doing substitution. Here's the key to substitution. When you have y by itself, you're saying that y is the same thing as x minus 3. Okay, do you agree with me? That's what y equals x minus 3 says, is y is the same as x minus 3. So up here in this first equation, if y is the same thing as x minus 3, I'm going to take out this y and put x minus 3 in its place. And now this is what it'll look like. 3x plus, and instead of that y, I'm putting in x minus 3, equals 25. Now, why is that helpful? What did that just do for me? Yeah. Now I just have x's, right? And if I just have x's, I can solve for x. This is just a regular equation now. So now I have 3x plus x is 4x. So now I have 4x minus 3 equals 25. What do you want to do next? Okay, plus the 3. Yeah, from here, this is kind of old hat, right? We've done this before. So 4x now equals 28. Divide by 4. And I have that x equals 7. Now remember that that's only half of my answer, because your answer to these are going to be coordinates. It's going to be like something comma something. So we have the x. We need to go back and find y. But that's really not going to be that hard, because right here we have y equals x minus 3, and now I know what x is. So I can plug that x value in right there. And I would get y equals 7 minus 3, which means y really equals what? 4. And so my coordinate, my final answer would be 7, comma 4. Okay. Does that make sense? And that's the exact same thing I would get if I took those two equations and threw them on a graph and then looked for the place where they cross. Okay? This does require you to be good equation solvers. That's why I've been driving home the equation solving for so long. Okay? You've got to be good at manipulating the equations through here. Let's try this one. Do I have something by itself? Yeah, I actually have two somethings by themselves, right? That's fine. I'm going to take what y equals down here, x plus 4, and put it in place of y in the other equation. Okay? Because I'm saying this is the same as y, so I can use them interchangeably. So now this is going to look like x plus 4 equals 3x. Any questions about how I did that? Okay with that, Leslie? What do you want to do to solve from there? Isaac?
Minus the 1x.
Yep, I would minus 1x. So 4 equals 2x. And then? Divide by 2. So 2 equals x. And then I have to go back and plug that in to find out what y equals. Now, it doesn't matter where you plug it in. In fact, back in this first equation, I could have taken that 7 and plugged it in for x here and then solved. That one just would have been harder because the y is not already by itself. If you're looking for y, look for an equation that says y equals blah, blah, blah. Okay? Both of these equations say that. So as long as I did this correctly, it shouldn't matter which one of those I plug into. If I plug into that first one, I would get y equals 3 times 2. So y is 6. Would I get that same thing had I plugged it in there? Yeah. So that's a good way to check and make sure that you're doing these right. Is that when you plug it in, it should work in either one of the equations. So final answer would be 2 comma 6. Good? All right, let's look at number 3. Do I have anything by itself? Does it say y equals or x equals? No. But which one looks like it would be pretty easy to get by itself? Yeah, that top one I could get y by itself just by moving the 2x to the other side. Okay? So if I were to move the 2x to the other side, this would then say y equals negative 2x minus 1. Okay, if I took this and subtracted 2x from each side. Okay, this is what it would say. Now I can take that negative 2x minus 1 and put it in place of y down here. Okay, so everything else in this equation is going to stay exactly the same except that y value. That y is going to turn into that. So here's what that would look like. Negative 3x plus 3, and then in parentheses, anytime you're putting more than like one term in place of the value, I would make sure to put it in parentheses. In fact, it wouldn't hurt if you just always did parentheses. So this would be negative 2x minus 1, and then I'm going to pick up here and write equals negative 21. Okay. What do I need to do to solve that one? Distribute, good. Distribute the 3, so I end up with negative 3x. This becomes negative 6x, and 3 times negative 1 becomes negative 3, equals negative 21. These x's are on the same side of the equation, which this is a mistake I still see. I see a lot of people get something like this, and then they want to say, okay, plus 6x plus 6x. If they're on the same side of the equals, you can just push them together. You don't have to add to both sides. Because when you do that, you're not really adding to both sides, you're adding to the same side twice. So this would become negative 9x minus 3 equals negative 21. Hopefully you'd be able to take it from there. We would add 3, so negative 9x equals negative 18. Divide by negative 9, and x would equal positive 2. Now I could take that 2 back to either one of my original equations, but I would always take it back to the equation where it's solved for something, because that's what you're trying to find. If I want to find out what y equals, I should look for an equation that says y equals blah, blah, blah. That's right here. Y equals negative 2x minus 1. So I'm going to take this, put it right up in there, and I guess I'll rewrite it down here. So I would get y equals negative 2 times 2 minus 1. Any questions? Oh, you can't see it, I'm sorry. Any questions on where that came from? If I've got this equation, I just plug the 2 in for x. That's negative 4 minus 1, which is negative 5. So final answer would be 2, negative 5. Again, same answer you would have gotten if you would have graphed both of those equations and looked for their intersection. Okay, this is just a mathematical way to find it. And number 4. Do I have something by itself already? I do. I have what y equals. This one's actually going to be really easy. Okay, probably this is one that you would get to on a homework assignment and go, wait a minute, I don't know what to do. But you do know what to do. It's easy. I have what y equals, right? Y equals 8. So y is the same as 8. I'm going to drop that in for y right here. And so I get 2x plus 5 times 8 equals 8. Well, this becomes 40. So 2x plus 40 equals 8. Subtract the 40 off of each side. And I get 2x equals negative 32. Divide by 2. X equals negative 16. What does y equal? 8. We already know what y equals. Okay, this told us y has to equal 8. So my coordinate would be negative 16, 8. Questions on that? Okay. Let's talk about what I expect you to show on your paper. Some of you are getting really good at equation solving, good to the point where you don't necessarily have to write out every step. That's okay with me. However, I do need to see wherever you have plugged one equation into the other. So like, for example, this right here, I should see this step. Okay, I should see where you have taken one equation and put it inside the other. And I should see most of your equation solving, but if you don't want to write out like plus 3, if you can go straight from 4x minus 3 equals 25 down to 4x equals 28, that's okay with me. Okay? If you're struggling with equation solving, I strongly recommend you take the quarter of a second that it takes to write that down and do it. Okay? I will warn you, this method, there's a lot of places for mistakes with like little negative signs and dividing the wrong way, and I mean just silly little mistakes. And I spend a long time, when we take our quiz over this next week, I spend a ton of time grading it because I go through like step by step and look for your little mistakes. So even when your answer is totally way off, if I can find that it's just a negative sign or something, that means that you still have a pretty good grasp on what to do and you'll still get most of the credit. So the more work you show, the easier it is for me to figure out where you went wrong. And the same thing here in class. If you're working on an assignment and you call me over and say, I don't know what the answer is to this one, I can't get it, I can't figure out what you did wrong if you haven't written down any work. Okay? So if you don't want to write out everything that I have here, that's okay, but you really should try to show me as much as you can so that I can find what you're doing wrong. Okay?